Hey everyone, let's dive right into this explainer. Today, we're going to uncover the unseen science and engineering behind Pakistan's food packaging industry. We literally interact with it every single day, right? Tearing it open, tossing it in the recycling, usually barely giving it a second thought. But what if I told you that the simple wrapper around your favorite snack is actually a total marvel of modern science? Seriously, take a second and think about it. Have you ever wondered why the exact same type of drink might be sold in a plastic bottle, an aluminum can, and a glass jar? Or why some foods come in stiff, rigid trays, while others are in those crinkly, flexible plastic films? I really want you to rethink those everyday containers you probably take for granted on supermarket shelves. Because, as you'll see, food packaging is so much more than just putting food inside a container to make it look pretty on a shelf. It is a highly engineered system.
So, here is our roadmap for today. First, we'll look at the invisible problem. Then, material science. Third is advanced technologies, followed by labels and sustainability. And finally, we'll wrap up with smart futures.
All right, let's kick things off with part 1, the invisible problem. We're talking about protecting food from the elements.
Every single time a food product leaves a factory, it faces what I like to call the enemies of food. First up, we have oxygen, which causes oxidation. Think of a sliced apple turning brown on your counter, or fats going completely rancid. Then there's moisture. Moisture is incredibly tricky because it can move in or out of a product. It's what makes crunchy things soggy or moist things unpleasantly stale. Third is light. We actually forget this one a lot, but UV rays can literally break down sensitive food components, degrade essential vitamins, and severely alter flavors. And finally, microorganisms. Those tiny, relentless invaders that cause outright spoilage and really serious food safety risks. So framing packaging as our scientific shield against these 4 specific environmental factors is absolutely crucial. The goal isn't just to contain the food. The goal is to actively help maintain its molecular quality and safety.
Moving right along to part 2, material science. This is all about designing the perfect shield.
Okay, so the foundational concept you need to know here is barrier properties. Honestly, this is probably the most fundamental concept in all of food packaging. It's the specific capability of a packaging material to block or at least limit the transfer of oxygen, water vapor, light, and all those other environmental substances we just talked about. Why does this matter? Well, because an oxygen-sensitive drink requires an entirely different molecular shield than, say, a moisture-sensitive potato chip. Food scientists essentially have to study the chemical interaction between the food itself, the package, and the outside environment just to choose the perfect barrier. And this perfectly illustrates why food scientists act sort of like matchmakers, pairing specific materials based on the unique vulnerabilities of the food and the conditions it'll face during distribution. Take glass, for example. Glass is an absolute fortress. On a molecular level, it is completely impermeable. That's exactly why the carbonation in a glass bottle of soda can't escape, and why it provides such an incredibly strong barrier for things like sauces and preserves. Its weakness, obviously, is that it's heavy and breakable. Then you've got metal cans. They offer maximum protection, completely blocking out light and oxygen, which provides immense durability for long shelf-life products. And then we have plastics and flexible packaging. Now, these aren't just simple sheets of plastic. They are highly engineered polymers. Sometimes they're layered microscopically to block moisture perfectly, even if they might let trace amounts of oxygen slip through over time. They are incredibly versatile and perfectly paired with snacks and frozen foods. Basically, every material has a specific, scientifically determined job based on product characteristics, shelf life, and even how far it has to travel in the back of a hot truck.
Let's step into the factory for part 3, advanced technologies, where we look at pushing the limits of shelf life. Now let's look at aseptic packaging. This is a fascinating journey of processing and packaging working together in absolute perfect harmony. It's an advanced system where a commercially sterilized product is filled into a commercially sterilized package under strictly controlled conditions. The sheer engineering behind this whole process is mind-blowing. This technology is the exact reason why products like UHT milk can just sit out on a warm supermarket shelf for months without spoiling or needing any conventional refrigeration before you even open them. To picture this, think of the journey of that UHT milk flowing through 3 vital, highly controlled steps to ensure absolute stability before it ever reaches a store. Step 1, you hit the food product with a rapid, ultra-high commercial sterilization process. Step 2, you do the exact same thing to the packaging material itself, completely eradicating any potential microorganisms. And step 3, you bring them together. You fill the package under incredibly strict, controlled environmental conditions where absolutely no outside air can interfere.
It really is a masterpiece of food engineering.
Okay, this next one is super cool. MAP, or Modified Atmosphere Packaging. This is an incredible technique, often used for fresh meats and produce, where scientists literally change the air inside the package. They replace the natural ambient air with a scientifically selected gas mixture to extend stability and shelf life.
To really wrap your head around this, let's compare it to something you're probably much more familiar with: vacuum packaging. While vacuum packaging just sucks much of the air surrounding the product out entirely to leave a tight seal, MAP actively replaces that air. It fills the space with a specialized, product-specific gas mixture. Maybe they use a little extra carbon dioxide to inhibit bacteria, or a bit of nitrogen to prevent the package from crushing in on itself. It's a highly calculated scientific intervention. But we do have to remember what our sources point out here. Packaging alone cannot make unsafe foods safe. Even with MAP or vacuum sealing, good hygiene, proper processing, and temperature control remain absolutely essential.
Zooming out a bit, let's hit Part 4, Labels and Sustainability. Here we'll look at communication and environmental impact.
When you glance at a label, you're not just seeing marketing. You are interacting with a highly regulated communication system between the manufacturer and you. The anatomy of a food label includes the product name, exact ingredient information, nutrition panels, net quantity, batch information, and crucial date marking and storage instructions. And you know that batch information? It isn't just a random string of numbers. It's an absolute lifeline for rapid traceability and recalls if a safety issue ever occurs. This entire label ensures that you, the consumer, can make informed choices, and it guarantees that the manufacturer is operating with strict regulatory compliance.
But here is where things get really tricky. We hit a massive industry balancing act called the Sustainability Challenge. We all know packaging waste creates serious environmental concerns, which has led to this urgent push for recyclable, lightweight materials and reusable systems. But here is the paradox. Sustainable packaging still has to provide the hardcore protection the food requires. If we use an innovative, environmentally responsible material, but it fails to act as a proper barrier and the food spoils, well, the environmental impact of all that wasted food, the water, the energy, the carbon emissions used to grow it, is absolutely devastating. It's an incredibly delicate tightrope walk between total food protection and environmental responsibility.
And you know, this entire science is deeply relevant right now to Pakistan's growing food processing sector. As the demand for processed foods, beverages, dairy products, snacks, frozen foods, and ready-to-eat meals continues to absolutely explode in Pakistan, the country urgently needs safe, functional, and cost-effective packaging solutions. Food scientists, packaging technologists, and engineers have a massive opportunity right now to innovate for local supply chains and elevate the entire region's food safety standards. Finally, let's look ahead to Part 5, Smart Futures, focusing on the digital transformation of packaging.
We are moving way beyond simple, static wrappers. The future is all about smart packaging. We're talking about digital labels and QR codes that connect consumers straight to vast databases. We're talking about intelligent freshness indicators that actually change color if the product gets too warm, and smart sensors built right into the plastic or paper, working right alongside advanced digital traceability. Just imagine scanning your next snack at the store and instantly accessing AI-enabled data about its origin farm, its factory processing, and its exact supply chain journey, all right in the palm of your hand.
So, to summarize this explainer, we really must shift our paradigm here. Food packaging is not merely a wrapper to toss in the trash. It's a complex fusion of material science, advanced technology, engineering, and product design. It really is a silent guardian, a carefully engineered system that is absolutely critical to both our survival by ensuring food safety and to our modern convenience.
So, I'm going to leave you with this. The next time you pick up a food package, will you see just a simple box, or will you see a marvel of modern engineering? Hopefully, after today, your entire perspective has shifted. Keep exploring, keep questioning the everyday objects around you, and I'll catch you in